This is the very first BS&Beer of the Carolinas, BS standing for building science, not something else. So again, thanks for being here. We have myself, Sam Myers. I'm with Retrotec, a building scientist with them. We're a diagnostic tool manufacturer. Chris Conway, who does a lot of building science work himself around the DC area. Nikki Krueger is here from Ultra-Aire dehumidifiers. If you keep up with the building science industry, you've probably seen her pop in on some videos or webinars or podcasts. And of course, Greg Nelson with Green Dot, who is a local HVAC contractor here in the Wilmington area. So the way this works, these are usually just really casual discussions. We'll usually pick a different topic each time we do one of these. And a lot of that comes from whatever it is that you guys want to hear, or a certain building science topic that could help you professionally. So please be vocal and let us know. We have a chat box. So if you have questions as we go on with this, please let us know. As you guys have probably seen in the description, when we posted this, we're going to be talking about some blower door testing and dehumidification. Yeah, someone's asking, where's the beer? Trust me, it's here. I'm drinking a Tropical Lightning from Wilmington Brewing Company, so supporting local.
When you comment, make sure down below that you click that panelist and attendees so everybody can see the questions also.
Perfect. Yeah, and we'll probably have a little time left over at the end, so we'll call on you if you want to elaborate on a question. Just let us know. You can just let us in the chat box. We'll be keeping tabs on that throughout the presentation. But today we're actually going to be talking about a house that we, the four of us, went to this afternoon. This is pretty fresh off the press. We were there at about 1 o'clock and spent a couple hours at a historic home in downtown Wilmington that was having some comfort issues. And so we're going to take it from there and kind of show you, what we found and what some of our ideas are about how these homeowners can move forward to improve their property. What do you think, Nikki? Did I miss anything in the beginning?
No, this is, again, hopefully at some point we can get these in person, but we'll always try to do them virtual as well, because we know a lot of these topics, especially for humid climates, affect a lot of areas. And so I think we'll go from there. I'm drinking wine out of a hotel cup. Sorry about that. Don't even have a classy Yeti to share.
You can't hide class, Nikki.
And I think what we said we're going to start with, Sam, is you're going to kind of go ahead and do an overview on some blower door testing and concept, just to make sure that we're all on the same page. I'm going to go into dehumidification, just basics. So as we talk about this project in detail, everybody has the basic understanding of the terms and what we were trying to achieve when we were visiting this house.
So I'm going to go ahead and share my screen here. And yeah, Nikki, thanks for mentioning that, because, after this pandemic, wears off and we can safely reconvene in public areas again, we do want to try to do these things in person, where we can meet at a brewery or a local bar or something like that and give some live presentations and just kind of network and get to know each other a little better. But for the time being, this is our best option here. So we appreciate you coming on and being a part of this. So as Nikki mentioned, I am going to kind of kick things off from the blower door end. This is going to be a really quick crash course on, what blower door testing is. I don't want to spend a whole lot of time on this because we have a ton of resources on this on our own website and YouTube channel. But I am going to give just a quick overview, because I'm sure there's some people that will be watching this that'll say, well, what's a blower door? And again, this will be recorded. So if there's anybody you'd like to share this with, we'll have this posted shortly after. So a blower door is what you see here in this right-hand picture. And it's a tool that we use to measure air tightness in a building. And up here, I say, why test? Why do we care about that? There's a famous building scientist named Joe Stiebrick who always says, no one ever calls me with an emergency phone call that says, help me, my building is leaking air. But over time, that can really affect not just the efficiency of the home, but the comfort and the quality of the air that we breathe, and sometimes even the durability of the structure itself. Because if you think about, what's in the air that we breathe, especially here in the Carolinas region, it's a humid climate that we live in. So there's a lot of moisture in the air. So if you're sleeping at night and you kind of get sweaty, but it's not really that hot, you don't really have good control of the humidity in there. You got to think about where that humidity is coming from. It's coming from the outside. And so having an airtight building kind of helps keep that better under control. But blower door testing has been around since the early 1980s. It's nothing new. But it's just now becoming mainstream because building codes and contractors are starting to understand that having an airtight building enclosure is really important to the overall quality of the structure. So this is probably a tool that you'll be able to start seeing more often as building codes start to improve. Unfortunately, here in North and South Carolina, it's not really a mandatory thing yet, but hopefully it will be there in the next few years. But in other states, it is required by code. If you're doing an above code program, like Energy Star or something like that, Passive House, if you've heard of that before, a blower door test is required to get that air leakage measurement. And again, that air quality aspect, indoor air quality aspect, is a really important piece of it. And it's been a hot topic throughout this pandemic because a lot more people have been spending a lot more time in their homes than they usually have been. And so if you have an older home, like the one that we're going to be talking about today, you kind of have to think about the things that end up in your walls, ceilings and floors, and the air that you're breathing that comes from the outside comes into contact with all this stuff, then makes its way in, then you breathe it in. So a buddy of mine, Joe Madosh, actually made this mock-up of some of the things that end up in a wall cavity of an older leaky home, and it kind of puts it into perspective, what it is that we're breathing. So whenever air tightness kind of became new to the scene back in the 70s and 80s, it was all about energy, and blower door testing, air tightness testing, making a tighter home definitely helps with that. But what we've seen later on is, it's really the comfort that a lot of homeowners begin to care about. And as Greg will tell you, and other HVAC contractors that are beginning to figure this out, when it comes to comfort issues, it may not always be an issue with the HVAC system or the airflow. It might be the building itself. And so it's nice to have that ability to be able to differentiate between the two. As my buddy Joe always says, the largest duct system in a building is the building enclosure itself. So it's good to know how that structure is performing and how well it's going to contain that conditioned air that we're creating. And the durability problems has a lot to do with the humidity aspect, because if we have poor insulation on a part of that building, it's kind of like setting a cold glass of ice water outside and then watching it condense on the side. But if you have a Yeti cup like this and put ice water in, it's not going to condense. So if you have that humid outdoor air hitting that non-insulated surface, it'll condense, grow mold, eventually rot. So not only is it important for indoor air quality, but it's important for the durability. So let's talk about how this usually happens in a home. We have really three main pressure drivers in a building that causes air leakage. Two are pretty obvious. We have a lot of fans that run in our home: the HVAC system, bath fans, kitchen exhaust. Of course, that's going to put pressures on the house and bring air in and push air out. But there's a third one. You can have no wind blowing outside. Wind is another one, of course. Wind will induce pressure on the building and cause the building to leak and then exfiltrate in other places. But if you have no wind blowing and no fans running, you have what's called a stack effect. And if you think of how a chimney works, it draws air in from the bottom and then exhausts it out from the top. Well, buildings work the same way, especially in the more extreme times of the year. So that warm, buoyant air is going to move upward and out and then draw in that cooler air from the bottom. And then in the summer, usually that flips. And so as we're conditioning inside and making cooler air, it'll drop and then exhale out the bottom and then draw in hot attic air from the top. And that can vary depending on construction types and things like that. But again, you don't have to really have anything moving, wind or fans, and the building will still leak. But some of the common areas that we see, for an existing home, to have a really good airtight building, you have to have what's called an air barrier or a pressure boundary. Those are really interchangeable terms. And for it to work, it has to be continuous. So really, if you were to take a sectional drawing of a house like this that you see here, you'd really want to put a pencil on one part, go all the way around and not be able to lift the pencil up and then finish where you began. But of course, we have all kinds of cracks and holes if we don't pay attention to that. So you see this big blue arrow in the middle. This shows an interior wall. So if we don't have everything sealed up there, we can pull in air from the crawl space, if we have a crawl space or a basement. If we have a slab, it can just come in from under the wall there. And then move upward and then out into the attic. And you don't necessarily have to have holes through the wall. I've got another. Yeah, so this is really the biggest source of leakage that I see in a lot of newer homes. This is looking at the top of an interior wall from the attic side. And what you see here on each side here is the drywall, the ceiling sheetrock coming and hitting the side of that top plate. And so you have a crack on both sides of that wall, which means everywhere you have an interior wall that's adjacent to attic space is going to be a leak, and that adds up to be a pretty big hole. And so that's going to be common in most houses. And you see this, this pipe here going through here. I mean, anywhere you have a penetration is just going to add to that as well. But these are some drawings here that we put together. I used to work for a company called Advanced Energy in Raleigh, North Carolina. And we put together a checklist for builders to show, what are some common areas where you want to pay attention to air sealing. And if you're looking at the wall itself, you're looking at this teal line here. And really, anytime this line moves is a potential to have an air leak. And so anywhere there's a corner or anytime one material changes to another material, that's just an important area to consider to make sure that that's going to be a tight assembly. And same for ceilings. Our ceilings have a lot of penetrations in them for HVAC supplies and returns, for lighting. Can lights are a big one, ceiling fans and things like that. So if that ceiling itself is going to be our air barrier, then that's something that we want to pay attention to. And there's just some photos from the field that show, if you're walking through a house at the framing stage, these are just a lot of things that typically get missed. Basically, anytime you can see daylight, if you're walking through a newer house that's getting constructed, if you can see light, air is going to move through there too. But yeah, this is that photo I showed earlier. If we were to try to fix that issue and seal that up, we would have to move that insulation out of the way, use a spray foam or a caulk to seal that up on both sides everywhere we have that kind of crack or penetration. And as you'll see in this house that we went to today, chases are a big one. So for example, in this house, maybe they were planning to run a piece of ductwork through here and then change the design, but they left this big hole here at the top. And this is essentially like having a window open 24/7 in the worst possible place because, I mentioned that stack effect before, so it's always going to be drawing air. So we always want to cap those. Corners are typically weak spots, like I mentioned before. We want to make sure that we have a good seal wherever one material changes to another. Windows, one common misconception that a lot of people think about when they think about, a leaky building is like, oh, it must be windows and doors. Where really, no, it's ceilings and floors. It's the opposite. But they are a big deal. We do want to be able to seal that rough opening up. So like using a low expansion foam like this, or if it's a tight fit, we can caulk it or put backer rod in there. But if for newer construction, that's where you tackle that. For existing construction, there's usually some lower hanging fruit that you can grab to improve the performance of that house. Like I mentioned before, the penetrations in the ceilings. So this is actually a return in the ceiling. And this is if you were to kind of stick your head halfway in there. And you can kind of see this gap here between the sheetrock and the return box here. So that's something that you want to seal up. Otherwise, that return is just going to suck in attic air, which is not something that you want to breathe. Can lights are a big one. Those are pretty common in more modern houses. So back to the blower door and how this thing works. Basically what it is, it's a calibrated fan with a high precision manometer that gets the house under a certain pressure, whether if it's positive or negative. We can either, force air into the house and pressurize it, or we can exhaust air out of the house and depressurize it. Either way will work. Depending on the scenario, one way might be, better than another. But the manometer that we use on this, or the pressure gauge, interchangeable terms, is very high precision. It's not going to be like your common pressure gauge that your HVAC contractor is usually going to have in their bag. These can measure, down to a fraction of a pascal of pressure. And if you know about inches of water, there's 250 pascals in 1 inch of water. So these are really, really high precision manometers. And the way we typically test a house, every standard for residential buildings is we test at 50 pascals of pressure. And that's kind of equivalent to about a 20-mile-an-hour wind on all 6 sides of the house. And so we test all houses to that same pressure just to put them on a common baseline. So the fan is pressurizing or depressurizing the house. The manometer is measuring the pressure in the house, so it can tell when that fan has gotten to 50 pascals, and it can tell the fan, like, okay, stop, you've gotten there, keep it constant. So it's measuring the outside versus the inside to see that. And then it's measuring the actual fan pressure itself. That's how we can calculate the flow. So the way that we actually interpret the leakiness of a house, it's CFM, or cubic feet per minute, at that 50 pascal pressure. So it's usually reported in CFM or air changes per hour, or ACH 50. And for that, you just have to know the volume of the space that you're testing. So if you go back and, if you read, certain building codes in other states, it's either reported in CFM 50 or ACH 50. Either one works just fine. And the last place in how this calculates flow is, it's measuring the pressure in the fan, and then you have a known hole opening here on the inlet side. And since the manometer knows what the pressure is and it knows what the area is of this hole, those are the two things that you need to calculate flow. Back in the day when this was coming up, you had to do all that stuff by hand. Now these manometers are like little handheld computers. It does all the math for you and just makes it super fast and easy. For the fan pressure, there's these little ports around the center part of the fan that picks that up. I won't go too much into this. If it's a topic of interest, just let us know. We can dive deeper into the weeds later on. So here's just kind of a diagram to show how this works. This fan is set up to depressurize the house. So we're getting the space inside, the living space, at negative 50 pascals. It's 0 outside and plus 50 around the skin of the building here. So we're basically just exaggerating the leaks through the house. And then since we know, the fan pressure and the known hole opening, we can calculate what the total leakage is of that house at that pressure. So you're making those leaks exaggerate a lot more than they are. And that's just another description just to kind of show, we're pulling leaks through everywhere we talked about. All those penetrations through the ceiling, through the walls, up through the floor. If there's a leak, it's getting measured. And, for safety things, sometimes it's better to pressurize and depressurize. For example, if you have a bunch of ashes in a fireplace, if you depressurize, you kind of risk pulling those all into the living room. I've done that before. It's messy. It's not fun. Always check the fireplace. But another thing too is if you have mold growing along the air barrier itself, you don't want to pull those mold spores into the living space. So sometimes pressurizing will be a safer alternative there. And for HVAC contractors that do what's called a load calculation, and if you're just a homeowner and you're watching this, if you're getting a new system, please make sure your HVAC contractor does a load calculation to see what size you need. Especially here in the Carolinas where we have high humidity. If they put something in that's going to be too big, it's going to get to the thermostat set point too fast, and it won't have a chance to dehumidify the space. There's really no good rule of thumb for doing this. They need to do a load calc to see what this is, and measuring air infiltration of the building plays a large role in that. I had a 1,000 square foot house in downtown Raleigh that we moved out of last year, and air infiltration made up 25% of the total heat load of that house. And I mean, there's no way to have really known that unless we would have actually hooked up a blower door and measured it ourselves. So, but for the HVAC contractors that might be watching that aren't really familiar with this, in different software, you can go in and say, okay, the house is tight, semi-tight, average, loose, and so on. But a lot of people just kind of guess at that and don't really know what it means. So, an average house, they're saying it's 4 ACH 50, but I mean, honestly, I see a lot more houses that are higher than that. And they're saying loose is 8 ACH 50. The house we tested today was 23 ACH 50, and which is way, way off of this chart. So really, if you're not testing, then you really don't know uh, what it is that you're dealing with, and there's a really good chance you're just gonna put a piece of equipment in there that's not going to be properly sized. So that's another reason why we really care about this, just so that we can match a piece of equipment to your house that's going to perform better than anything else. And we get this question all the time. Okay, well, how tight is too tight? There's a big myth that we've been fighting. People that work in the building science industry, fight this uphill battle because everybody keeps coming back and saying, well, no, houses need to breathe, and that is not true. Houses need to ventilate. People need to breathe clean air. That's one thing that we keep finding ourselves saying over and over and over. So really, you can get a house as tight as you want to. I mean, you can get it perfectly tight if you want, but you have to have a good ventilation strategy once you get to that point. And you can do that a number of ways. I'm not going to steal Nikki's thunder because they have a great product that does it too. But there's all kinds of ways you can hook up mechanical ventilation so you can actually bring in outside air from a certain space, filter it, and then bring it inside. So there's definitely a lot more than one way to skin a cat there. But again, that's something else we could spend a couple of days talking about. So I want to go back to this whole stack effect issue. This is actually something I did last night at my house, just to kind of show that you can actually watch stack effect happen in real time. So this is one of those high precision manometers that comes with a blower door. And so what I did is I went upstairs. We have one room upstairs. There's a bonus room right above me in the garage. It's my wife's office, and it stays super hot all the time. And so I put a probe up underneath the wall there, just touching the bottom plate. I can get under that baseboard. And then I went downstairs, and I know there's a big hole under our tub in the master bath. And so I found a crack by that tub and put a probe in there. And I hooked each end of it to each end of this manometer. And what I'm seeing, this 1.2 pascals, that's how much air is constantly coming into the house without any fans running or wind blowing. And then this -3 is air escaping out the top. So that's always happening until I go and I seal that stuff up. It's going to keep happening. So during the winter, I know a lot of the time our downstairs is cooler, our upstairs is really hot until we start to cap this stuff off and seal it up. It's not going to change. So there are ways where you can, plug things up and actually see, how much of that stack effect is there. Nikki, it's all you. That was a big crash course on air tightness and blower doors. And, we can go down a number of rabbit holes, but that's just kind of a quick and dirty introduction to it. So.
All right.
Nikki, it's all yours.
I'm going to hopefully be able to see my screen here. We're going to make this short and sweet because I really want to get to the photos and talk about our experience today. So for those of you who don't know, Ultra-Aire dehumidifiers are manufactured by Thermistor. We invented the whole house ventilating dehumidifiers. Santa Fe is our crawl space and basement. Quest is our commercial. Phoenix is our restoration line. Basically, if it has to do with dehumidification in any capacity, we do it. Manufactured in Madison, Wisconsin. Just so we understand going through this, some basic terminology. Sensible load is the load that the thermostat is trying to get to. That's the temperature we feel. The latent load is the moisture in the air. And we oftentimes count on our air conditioner to handle both of these, but we're seeing more and more challenge with those moisture loads. So especially in this climate in the Carolinas, hot goes to cold, wet goes to dry, and high goes to low. So a majority part of the year, our houses are trying to fight the forces trying to come in our homes. So when we do have leaky homes, cracks and crevices, that's what we're dealing with coming through our walls. So there's a bunch of factors that can lead to high humidity in the homes. We typically talk more and more about tight houses and how we're trapping that moisture inside, and mechanical ventilation is adding to those loads. And then we have these really high energy efficient equipment with high sensible heat ratios. which don't do a really good job of removing humidity. No matter what, all these things can add to the moisture load, and then you put people in there, which generate moisture, and then you give them control of that thermostat, which is supposed to control the sensible and latent. And the reality is we all control a thermostat differently. How I control it is very different than how my husband controls it. So if we're counting on that thermostat and people to run the house like we design it, that is not always going to be the case. And we see this more and more when we start dealing with multifamily and get into maybe senior housing and that sort of thing. They don't want the thermostat below 78 degrees. So we've got to think about other ways how we're going to control the moisture, because moisture is the #1 detriment to our homes. So we need some sort of dedicated dehumidification, typically in the Carolinas, for comfort, health, and property protection. We've got a lot of times of those shoulder seasons, spring, fall, overnight times. We're not running a lot of air conditioning. And again, the tighter our houses get, the whole goal is to run less air conditioning. We've got this really energy efficient equipment. We can't control human behavior, and it's the only way to ensure 50% relative humidity. So a whole house ventilating dehumidifier. Again, we did invent this technology back in the mid-90s. It integrates with the HVAC system and is designed to control the relative humidity of the house to a certain set point, separate from the air conditioner. So our units have MERV 13 filtration. You can ventilate with our dehumidifiers. We are a supply ventilation tool or equipment. So we'll bring in air from the outside, filter it, and try to get a slight positive pressure on that house in order to stop that infiltration from the outside. We have a whole lineup. So depending on what size the house is, and it, great to know manual J's. If you know that latent load and we know the sensible heat ratio of the AC equipment you're using, and we know the air leakage, that gives us a really good idea of what kind of ventilation load or what kind of latent loads we're dealing with. And knowing ventilation loads also helps tremendously. So our recommended install is a dedicated return to the supply. You can find this information on our website. Just a heads up, Florida Residential Building Code now has included 2 install recommendations, which again, doesn't really apply to the Carolinas yet, but we do know that when code makes it in one place, other states start looking at it. But this is one of the main installs that is recommended. So we pull a dedicated return to the dehumidifier and then tie into the supply to distribute that dry air throughout the supply ductwork and through the house. We got a video here how to show that, but I'm not going to show that right now, but you get the idea. If you are using ductless mini splits, this is a great install to utilize our dehumidifiers, because we can bring in that ventilation air. We can also do some of that air distribution throughout the home so we don't get stagnant areas. We've got MERV 13 filtration, so the house gets really good filtration. And again, dedicated dehumidification. We know that when you start using these really energy efficient systems, such as ductless mini splits, you are going to lose, you're not going to be able to get a lot of the latent removal that you need with that. Return installs. If any of you are familiar with dehumidifiers and installing them, this is probably a very common one you see. It is in our manual on our website. It is our least favorite. Sometimes it's the only thing that you can do in retrofit, but if at all possible, stay away from this install. Reason being, Florida Solar Energy came out with a study a couple years ago to actually verify, which we already knew. When you do a supply to supply install with the dehumidifier, you heat up the coils on the AC system, which reduces the amount of moisture the AC system is going to remove. And then also any water left on those coils, if the dehumidifier comes on, is going to be re-evaporated and back into the house. So I actually had a contractor call me this past summer, put in one of our dehus, swore up and down it didn't work. The RH was going up in the house, asked, how he installed it. He said that return to return, had him go in and switch it up, return to supply, and everything worked fine. So again, it's a tricky one to get right, and we just stay away from it at all possible. Energy is always one of the factors that come in with any dehumidifiers. They're known as energy hogs. The reality is we manufacture very energy efficient dehumidifiers, and all the commercial components used in our commercial dehumidifiers are used in our residential. So you get really good quality and very good energy efficiency. So a lot more water removal with a dehumidifier versus trying to utilize that AC to overcool to dehumidify and potentially create more issues. So Red Calc has this calculator on their website. I just use it to show, how much energy, use the ventilation, electrical usage, put in our watts, and it'll pop out there for you what kind of energy usage you're looking at for our dehumidifiers. So there's Sam used to work for Advanced Energy. We had David Treelevin on here, who's now a colleague of mine that used to work for Advanced Energy as well. They've got great research on crawl spaces. We know that if you encapsulate that crawl space, that you're going to be able to control a lot of moisture below that house. Which is very important because vent and crawl spaces do not control moisture. 50% of the air in the home starts below the home. So whatever's down there, mold, bacteria, all the contaminated air is rising up through that house and creating indoor air quality problems. So a lot of times if I have homeowners say, do I need a whole house dehumidifier? The first thing I ask is if they have a basement or crawl space and what's going on below there. And let's get that underneath control before we worry about the rest of the house, because oftentimes that will reduce a lot of the moisture in the rest of the house. And I think we are going to fly into the pictures that we have in the situation that we talked about today. But what's important about, as we talk about this, is, traditional homes are very leaky. And they were designed to breathe. There was no control of the flow of the air in the home. Indoor air quality was not controlled. Energy bills were high. If you needed a dehumidifier, somebody did something wrong. And the reality is we look at these historical homes like we did today, they're not really in their traditional state. There's been energy updates made to try to make them more energy efficient, more comfortable. And the reality is you can create a lot more problems by doing that, which is exactly what we ran into. So before we go any further with the pictures, I just want to have Chris Conway and Greg go a little bit more into introducing themselves and tell us what they're drinking, because really that's why we're all here.
Hey, Nikki, real quick.
Yeah.
Reedy Ward had a question for you there regarding static pressure for systems.
All right. What was that, Reedy? Let me see. For the HVAC and the supply, the HVAC, does the max static mean for the supply only? Yes, for the supply. So max static pressure on that supply side that you can hook a dehu to, that we recommend for most of ours, is 0.4. I will tell you that some of our units can handle more. We've got stronger fans in there and they can handle more, but the manual is going to say for all of our units, if you go above 0.4, stop, give us a call. Because again, we are really the ones who can handle the most amount of static pressure. That's why that's our recommended install. But again, we don't want to compromise the system. All right, I'm going to stop sharing. And while we switch over to those photos for Sam, Chris, why don't you go ahead and introduce yourself?
So I don't have any fancy slides. I don't have any of that cool stuff. They just brought me along for the eye candy. My name is Chris Conway. I'm out of Northern Virginia. I am married to Nikki Krueger. We primarily deal in the sustainability design, verification a lot of building science stuff, multifamily homes and some multifamily buildings and high performance homes in the Northern Virginia, DC area. And we've been working on kind of the forensics and the moisture work for, I don't know, over a dozen years now. And so they were kind enough to drag me along and let me lend a hand a little bit today to see if I could lend anything. So happy to be aboard.
My turn, I guess. So Greg Nelson, president at Green Dot Home Services. We're a local HVAC contractor here in the Wilmington area. We also have an operation in Columbia, one in Mount Pleasant. So the way I got involved in this was the initial call came into our company regarding this home, went down, did a site visit. This was probably 5-6 months ago. Between that time, I was lucky enough to meet Nikki through Rob Howard and some people at Yandell Witherspoon. And that relationship has just grown and grown. Through Nikki, I met Sam. And with their guidance and help and whatnot, we're starting to grow this side of our business. We always did really, really high-end installations and things like that. But we wanted to take it to the next level. And that's what we do here is trying to figure out how to solve problems that other people maybe don't have the skill set at this time. So that's kind of the premise behind all of this was we all got together and said, hey, let's kind of all collaborate and see what we can come up with. So that's kind of how all this got started, and here we are.
Hey,
Thanks, Greg. So if you would, let's talk about this house a little bit. And, these homeowners came to you with an issue. They had a problem. So what was the pain they were looking to get relieved?
The initial call came in, hot spots in the house, never comfortable, somewhat unbearable in the summertime. And that was the initial call. Went down there and they told me it was an older home. I don't recall if they said it was a historic home. This home was built in 1875, if I remember what the plaque says. So obviously lots of issues. When I got there, 13 SEER Goodman, single stage, no bells and whistles, a really dodgy duct system. And we talked about some solutions, and then it kind of went dark for a little bit. They had some things going on in their life, called me back, and I went down to see them again and said, hey, let's take a pause on this. Let me make a phone call to a few people and see if I can't get them down here to do a site visit. And let's figure out the real solution that you guys are going to be happy with, instead of just throwing something against the wall and seeing what sticks.
Hey,
So-
Sam, do you have the picture of the house to start with?
I think it's actually at the very end.
Oh, is it?
Yeah.
It's just so we can kind of see. I hate to do that, but it's nice
No,
to
it's
be
all
able to
good.
see what we're talking about before we get to there. Yeah, there's challenges here.
Yeah. I mean, it's a beautiful house. It's been there since, that part of downtown has basically been around. So it's definitely seen a lot, but let's go back up to the attic, because really that's where the bulk of the issues were that we found. I mean, now you kind of see the gist of what this house is. Just a 2-story home on a crawl space. But, somebody sold them the idea that this, loose insulated radiant barrier was going to do something for them, which was, had to have been expensive to put up. But, there's been some things tried in this house before that haven't worked, attic fans, this thing. So
Here, this picture shows 3 different insulations that we have, that picture before. So there's been quite a few contractors in there.
Yeah.
We've got yellow, pink, and white now. So
all the brands.
And it's important to see this because there's going to be some dodgy stuff. And that means all of those contractors saw what was going on.
Yeah. But you got to keep in mind too, I mean, there's, you know, building science isn't a commonly known thing across a lot of trades. So hopefully it will, you know, begin to catch on more. But is this Chris, did you take this photo? Is this the drop down ceiling in the closet?
So this is so when we kind of crawled into the back, there's you know, little sections that some are easier to get to than others, and those who have met me know I'm not the smallest individual. But after I squeezed back in there, I started looking around, and underneath a lot of ductwork in the trunks, I noticed they're just flat out completely uninsulated areas. So all three of the I guess insulation contractors just decided that they didn't want to bend down and start blowing in underneath here. So there was areas like this all through the attic space where there was just no insulation. And it was amazing that three contractors, you know, decided they were just going to miss this area. So, but that's what that is there. That's just probably a 10 square foot area, maybe an 8 square foot area that just wasn't insulated at all. And those were dotted throughout the attic if you really looked hard enough. So that was just kind of the tip of the iceberg when we started looking around.
Those were showing up on the thermal images from the conditioned space side as well. I think this is the fun part here. So right when you get, you know, into the attic from the kind of the scuttle hole entrance, there's a closet that just has a dropped ceiling, and which of course allows that attic air to communicate with the rest of the house. So they had this foil backing that's on top of it, it wasn't really firmly secured down on anything. It was just kind of laying on top, and you could pull that up and then basically look down into the conditioned space.
Yeah. So what we were finding as we were kind of going around was that some of this foil backing was just laid on top of the trusses, and they were blowing on top of that. So nothing inside the cavity was blown in at all. So the cavities in a lot of instances were completely empty. You know, they were kind of just putting this foil over it, and then they were blowing just a few inches on top of that. So I don't know if the previous contractors were pretending that they were blowing in enough to fill all the cavities plus, but none of the three of them had done that in the past. So pretty interesting. But right here is where we pulled something up and we started to find a little surprise. So
yeah, it just shows that a continuous air barrier with the in contact with the insulation just isn't as widely known as we'd like for it to be. So I got to give a shout out to my buddy Brent Lammert. He's local to Wilmington as well, and he's an exec for a thermal imaging company called Hike Micro, and he gave us a few prototypes that we could take into the field and try out. And this is one of the handheld models, but you'll see some more thermal images later on as we go through. But here you can really see some of that heat from the inside of the conditioned space start to come out. We were pressurizing the house with a blower door to about 20 pascals of pressure. So you could see some of the heat from that conditioned space start to come up out of those leaky spots in the attic there. And that's
so
looking
this picture,
down into the cavern.
Yeah, so this is down inside there. So if you saw that last infrared photo, you saw me kind of peeking my head in there. What I was doing was getting ready to take this photo, and really I could stash all of us in that space if we so desired. It was quite a tall chase that went in there. That what I felt is I was kneeling down on the floorboards, and I felt the gust of air come up, and that was Sam turning on the blower door. And I'm like, what is going on? And then so I started to look around, and when we started to pull up the insulation, we found this giant chase, which was probably 3-4 feet deep, and extended the entire length of the attic, side to side. And it was a huge pathway of air that was coming up.
This is a closer look at it. But yeah, all that's
Go in the other
connected down
direction.
into the conditioned space.
Yeah.
And you can see little giblets of all three brands of insulation that have made its way in there over the years. Just some more thermal imaging here. We see that interior heat start to come up to the exterior. So this house has 3 big brick chimneys in it as well. And it had, some of that other foil backing up around it. But again, it was just loosely laid on top of the attic floor up there. And so once you pull that back, you can, around 2 of them, there was about a 6-inch gap. And you can really look down that chimney down into the conditioned space. And I think the one furthest back, Chris realized there's actually a much bigger hole beside the chimney than the other 2. But that's a significant part of
my hand
why this
photo
house was so leaky.
on? Yeah. Is there one with that my hand in there? Is that one next?
Not sure. But this is one of them beside the chimney. So that's looking straight down and basically into the house there. I think this is that closet. Yeah, this is that closet where that drop down was. So when we found that first initial drop ceiling, this is actually it, and it goes all the way across this wall here.
So so the homeowners had a certain area in the house that was very specifically the worst area. And after investigation, we started to see the chases, the fireplaces, the 10 square feet lack of insulation, like things started to add up. And as Greg will tell you in a heartbeat, as he already alluded to, is the ductwork was a hot mess. It was leaking everywhere. We have ample photos of ducts being sealed with actual duct tape, which is not the correct amount of tape, the correct kind of tape. The lines were being squished, technical term. So not only were they having really poor kind of an envelope situation, but the ducts, the mechanical system just wasn't able to do the job based on the install and the implementation. So I think we're going to get to that here in a minute, but that's kind of a heart.
Yeah, so we had the blower door set up, and we used the Retrotec 6000, which is a commercial grade blower door. That's a high output fan, has its own separate variable speed drive, and still could not get the house to 50 pascals of pressure. So using to extrapolate it, that 32.6 was the most we could depressurize the house. We're looking at 23 air changes per hour at 50 pascals, which is stupid high. A lot of the codes across different states now are anywhere between 5 to 7 air changes, for newer construction. But yeah, when you have a number this high, there's no way you're going to control comfort in that house. So there's going to have to be some shell work, especially there at the top of the house, to be able to start taking back control of the house to make it bearable. So we took some thermal images. This is, lifting up that foil by that attic door and seeing some of that warm air come out from that drop ceiling that's over that closet. And today wasn't the best day to take thermal images, unfortunately, because there just wasn't that much difference between the temperature outside and inside. So we can see some of the heat there if we really stuck the camera into that chase. But this, we were able to actually see that ceiling drop. This is actually in the bedroom adjacent to that closet. And about midway through the photo there, you can see that whole cavity. So that entire thing there is connected to the attic. That's one of the spots that Chris mentioned earlier that just didn't have insulation and contact with the ceiling. So if you walked around with a thermal camera with this house, you would see several blotches like this where there just wasn't any insulation in contact. So actually, I went out to this house a couple of weeks ago and did some initial testing, and fortunately it was a colder day. So when I depressurized the house, I could actually see that cold air coming into that, coming down that shaft for the chimney there. So that's just cold air coming down from the attic as we're depressurizing the home. And there's a return on the first floor, and we've got a picture of it in one of the crawl spaces later on. But basically, part of that return coming up from the floor was using the floor joists as part of the airflow pathway there, and it was super leaky. And as we were doing the blower door test on the house there, we could see some cold air come up from out of that crawl space. So that's coming from around that return up underneath the stairway. Did some smoke testing too. So this handheld fog emitter is really nice for identifying air currents. So we were pressurizing the house at this point, and unfortunately, for wall leaks like this, you really can't do a whole lot without ripping the wall out completely. But this just shows how you can identify some of those leaks with a fog emitter with the blower door. I think this is the picture you were looking for, Chris.
Yes, sir. That's yeah. We started pulling back more and more and more, and you know, if I were to lose a couple pounds, I could go down into that hole as well. And so anyway, they were just all over. It's a wonderful house for crack addicts. So for those that love to find cracks and infrared images, this is a great house for that.
So now we've got some photos here of the HVAC system going on. Greg, I'll let you talk to this, just to kind of give an overview of what's there.
Gas furnace downstairs was operating. I mean, it felt fine when it was running. The big thing that we were kind of looking at today was the upstairs. That Goodman system is at the end of its life expectancy. Obviously here in Wilmington, our equipment doesn't last as long as it would, say, in Charlotte or wherever else. We have that coastal environment tears equipment up here. So this system up in the attic, the air handler was in very, very bad shape. Duct system is in really bad shape as well. Poor design, poor execution. In my mind, it's scrap it all and start over with just a better mousetrap. Right now, my initial thoughts for a replacement system would be a Mitsubishi 2-to-1 system with some fan coil units. That way we can zone the upstairs with each fan coil unit operating basically 2 rooms. And it's easier to execute the duct system that way, easier to make sure that we're getting good airflow to all the rooms that way. Right now, the duct system is roughly 35, 40 feet. It does not taper down, so we're not gaining any velocity back. There's just a lot of things wrong with it. And at this point, I would say scrap it and start over.
Yeah, so Rob Howard is on here and has basically just been throwing a bunch of shade in the chat box, but now he's happy, Greg, so he really appreciates that.
I know, right? So I'm sure they're looking for a deal, Rob. Will that make you happy? There you can see the air handler there. A lot of times a telltale sign of how the interior of that air handler is you can look at that secondary drain pan, see a lot of corrosion there. That would tell you that it's most likely a coil with 2 dissimilar metals that are starting to eat themselves up, and that rust coming out is just that galvanic action that's taking place inside the air handler. And if you scroll in close enough, you can see that there's actually a turkey baster in that little metal pan underneath the secondary. I think that's how they were getting water out of the secondary pan.
True building science right there.
Yeah. It was quite the setup they had going on there. They were doing whatever they had to do to keep it running. But it is time to move forward and put in a better mousetrap. Ductwork, returns, laying over branch ducts, getting crushed. So, air supply, really tight corners on flex runs. It's basically everything you don't want to do was done in this house, from HVAC side, whether it was the ductwork, not the best equipment for this home. You can see there, exposed boots, none of those saddle collars, or I'm sorry, saddle collars had any balancing dampers in them. So no way to control flow to rooms. Right now, everything is taking the path of least resistance. So we are not able to kind of tweak this and make things, there you see the inner liner, you know, it's just, it's in bad shape all the way around.
Yeah, that's your actual duct tape used on
Yeah.
ducts.
Yeah.
Yeah,
The one place where it doesn't belong.
yep.
But yeah, we didn't do a duct leakage test on this system. You know, when I ran the blower door a couple of weeks ago, I could actually pull some leakage through some of the floor registers with the pressure pan and just see that there was a big pressure differential there. And you know, I could identify some leakage pathways with the smoke emitter as well. So we know they're leaky. And this duct system will likely get redone anyway. So we didn't really see much of a need to go ahead and test it. It would basically just reaffirm what we already know.
I think the next picture shows that.
Yeah, and from my side of the house, I wasn't saving any of it. So I don't care what the test came back as, we're starting over if I'm doing it.
Sure. Speaking of dehumidification.
Yeah, I talked to the homeowner and they had one of these on each level of the homes. Again, historic house, lots of wood. They have beautiful furniture, you know, that's antique and that's what they've been running. So, you know, crawl
Good
space,
fire source, right, Nikki?
What?
Aren't those a really good fire source too?
Yeah, they could be. You need to check to see if those have been recalled or not. But, you know, crawl space, we can go through that real quick. Basically, they did an encapsulation ish, or more of a closed, I would say. It's a closed.
It's a work of art, really.
Someone took a lot of time going through. I mean, I would have just thrown liner up on the wall, but you know, it's not the best install. But you know, what we really talked to the homeowners about is, you know, we didn't see a lot of moisture issues in the crawl space. They really had gone to great extents to control the moisture, getting it away from the house as much as possible. And it had made a big difference. They closed it up and we didn't see a lot of evidence of mold or anything down there. And that's because of, as of right now, you know, we've got the stack effect going on. So that moisture is coming up through the first level, the second level, being able to go out the roof. But the solution that we proposed, and I'll let Chris talk about this a little bit more from a, you know, what's the plan moving forward, is we are going to have to monitor that crawl space because the hope is we can air seal and put a cap on this as much as possible. And then there's a good chance that moisture that is being generated in the crawl space potentially is going to make it up through. So I'll let Chris talk about, you know, the air sealing strategy from here. And then I think Greg's already talked about the potential of what we're going to do for the HVAC, but it is going to be a phased approach because, again, these old houses, you got to take it slow. We can't do too much at one time without understanding the consequences of potentially what we could create.
So I learned lessons while working on houses, historic homes in Washington, D.C. And the first thing I learned is that these old homes are their own living organism. They have learned to live and to adapt with the environment, and they are fine without us. The worst thing we could have did to them is move in and add air conditioning to the system. So, you know, when we got up there into the attic, there's a number of solutions you could do. You could spray foam the roof deck. You can air seal the flat. You know, I think, and it's my opinion that you don't touch the roof and the venting that happens in there. That roof has been drying and wetting for over a century, and you don't want to mess with that. So what you want to do is you want to put a cap on the ceiling. You basically want to remove that 3 layers of fluffy stuff and expose those chases and all that. And you need to start air sealing that from the kind of, well, bottom up, the ceiling up, where you would basically remove all that, spray foam the floor in some capacity, cap all the chases, do all that, and then put all your fluffy stuff. Now, before all the fluffy stuff goes in, you know, I would suggest that Greg would come in and do the zone system as he would like to do, because it's perfect opportunity for his team to get in there and do all the great work without actually ruining all the air sealing and stuff that's going on up there. Anything you want to add to that duct stuff or the HVAC stuff, Greg?
I mean, obviously, you know, once it's cleaned out and we have access to, you know, sealing boots and everything like that, it makes our job easier. You know, like you're saying, Chris, the one thing that always worries us is coming in and maybe doing one in a crawl space that's just been encapsulated, and they got this beautiful barrier down now, and we're dragging metal through there and doing our best not to jeopardize that in any way. It's always a big concern. But like I said earlier, with the Mitsubishi system 2-to-1, I can do smaller duct runs, manage it better, execute it better, and make sure that we got good airflow going to all the rooms. And it gives the end user better control.
And then I think we talked about, you know, when we use these really high efficient Mitsubishi systems, that
Right.
pairing it up with a whole house dehumidifier so we can really control those latent loads.
Yeah.
And let that system focus on getting to that sensible. Of course, we want to size it so it runs and removes as much moisture as possible without overcooling, creating comfort issues, potential condensation areas. But really, that is going to give them the ultimate comfort system at that point. But once we do that, again, we gotta monitor that crawl space, because we're not really sure what's going to happen down there once we put that cap on.
You know, the other thing too, Nikki, like you alluded to, was that, you know, we have a team that goes in there and air seals and does all this. At that point, it's probably a good idea to get Sam to come back in and do another blower door test, conduct another load calculation, and see where we stand after we've done this work, and then hit the HVAC side, because, you know, we could be grossly oversized once we start sealing some things up. So, you know, we'd probably go back to, you know, the go from after we do some work.
And if any of you work in, I mean, historic, the homeowners today, just sharing their story, bought it in 2015, didn't move in until 2016, went up, you know, was kind of trying to figure out how to work with the historical society to make changes to this home. And so it would be comfortable. And, you know, they really seem to have butt heads to a certain extent. I mean, it was like pulling teeth to get a kitchen window switched out. So they want to make these homes better. They want to make them livable with a certain expectation of what comfort and sustainability should be. But what we've learned in these historical homes is once you change one thing without being able to really address the entire home, we see a lot more issues created, and then they're harder to work on and to solve because of the constraints of the historical stuff.
Yeah, Jennifer, the homeowner, stated today to me that she always wanted to own a historic home, just, you know, loved the idea and wanted to check that box. And she said, you know what, I'm getting to the point where I'm tired of that box. So, you know, it's frustrating, like you're saying, Nikki. They're trying to make improvements and everything, but there's a lot of pushback.
Sad.
Unfortunately, that's how this usually goes. I mean, you, as a homeowner who doesn't really know this stuff, you're going to try all kinds of things until you just get tired of it, until you finally hit someone who knows what they're talking about. And then by that point, you're tired.
And it's hard because today, I mean, as building scientists, we're up in the attic and we're digging and we're finding things. And to us, uncovering this kind of stuff is exciting, but then we all look at each other and go, you know, who's going to tell Jennifer and her husband, because this is their home, and it's sad that we're finding this.
Yeah.
So
it is, but it's, you know, there's a light at the end of the tunnel now.
Exactly.
At the same time.
And it's, again, doing that phased approach and not throwing everything at them at one time, and really saying, you know, here's where we got to start. And of course, I mean, I'm a manufacturer of dehumidifiers. Of course, I want to sell them as many dehumidifiers as possible. The reality is we don't want to throw too much at them, and we want to get it to a point where it works, and then they're happy. And that makes,
Yep.
you know, that's good for the contractor. That's good for anybody working on this house. Is let's just get them to the point where they're comfortable in this home.
I want to spin this just real quick and let Sam kind of piggyback off of this, because I want everyone to understand the value of a blower door test, because yes, obviously it's very easy to see it in a home like this, but Sam did a blower door test for us probably a month ago on a house that, what year was that house for Steve's house, Sam? It's 5-6 years old at most.
Yeah, I mean, it was fairly new.
And Sam did a blower door test on this house. You know, a very nice house, found the master bedroom suite 25% connected to the outdoor atmosphere on a 5 or 6 year old house that was reportedly built by a good builder within the Wilmington area. So the value of a blower door test isn't just on historic homes, it's all the way across the board. We did work, Nikki was out there with us at a $9 million plus house on Figure 8 Island that had major infiltration issues. Blower door testing was done to find the root cause. So there's a huge value in the blower door testing. You know, like Sam alluded to earlier, it's not always HVAC. We are usually the guys that get called first, saying that something's uncomfortable. So if you're in the HVAC industry and you don't understand this and understand the value of it, you know, start digging into it, because there's a lot of times these two worlds collide. And if you don't kind of have a little bit of a knowledge on it, you could just be going down the wrong road.
Yeah, very good.
Sure.
Thank you guys so much for joining us on this first one tonight. I know we went a little bit over.
Yeah, we're about 10 minutes past our hour, but
We're passionate people, but this was a great case study to kind of kick us off, because I always talk about new homes, but getting into this was fabulous, and would love for you to provide topics on, you know, if we do these, I think the thought is maybe monthly topics that we might move forward on, or people that you would like to see on here to provide more info. Again, this is building science. It's not just HVAC. It's not infiltration. It's the house is a system that we need to.
Or if you have an interesting project that's really unique and something
Yeah,
wacky is going on, yeah, bring it. Let's hear about it. So, but yeah, I want to thank I want to thank Chris for coming on too, because his input and expertise with historic homes was a killer addition to this today. So Chris, thanks for coming down. And Greg, I don't know how you keep getting Nikki to come down every time you have a new project going on, but you know, more power to you.
Because the weather's better here than it is up in Northern Virginia, the
Yeah,
DC
there you
area.
go. There you go. The contact info we can put up on the Retrotec website for now, but our hope is that we get a website set up for the BS&Beers Carolinas, and get the YouTube videos linked and topics, and go from there.
And hopefully we can see you all in person, you know,
Yes,
in the
soon.
not too distant future.
Soon.
I heard Rob Howard said he would buy the first round, so that's exciting.
I heard him say that too.
Well, we do have a couple Yetis to send out. Dan, you'll get the first one, and I got another one. So we're going to go ahead and do a random selection here and get another one sent out. So thank you guys for joining us, and we'll let you know.
I think Reedy needs one too.
I think Reedy needs one. He asked.
Reedy asked the most questions.
Yeah.
You know,
Good.
Actually,
good call.
they were pretty
Reedy.
thought provoking. So yeah, I think Reedy needs one.
I learned a lot. I should get one.
You have to put up with your husband. You get one.
Coming out of the corner, out of nowhere.
I've
Well,
been
cheers,
here,
everybody.
guys.
Have a good night.
Thank you.
too.
Cool.
Here's all.
Bye.
Bye.
Thanks, everyone.